Hi, my name is Sundaresh. Servicing a cylinder head involves a lot of inspection activities of various cylinder components like the cylinder head, camshaft, valves and its parts. Now we are going to learn how to inspect the valve assembly components. At the end of this demonstration, you will be able to inspect valve spring.
Tools required. Trainer's tool kit. Surface blade. V-block. Micrometer. Dial test indicator. Magnetic base. Tri-square. Equipment required. A valve assembly components. Materials required. Cleaning solution. Soft cloth. Valve assembly has the following parts. Valve. Valve spring. Valve retainer. Split lock. The nomenclature of the valve is shown here. The valve head sits on top of an engine directly over the pistons and encloses the combustion chamber. The valves are fitted in the cylinder head facing the piston and are held in place by having their stems running up through a valve guide seal. This is located inside the valve spring. A valve retainer and keeper clip hold the entire component in place. The valve which allows the air to enter inside the engine is called intake valve. The valve which allows the exhaust gases to escape to the atmosphere is called exhaust valve. Usually, the intake valve is 40% larger than the exhaust valve. Due to the continuous operation of the valves, it will be worn. The worn-out valve leads to a gas leak or oil leak. So, the engine power will reduce and carbon deposits will form. The continuous operation of the valve causes the margin thickness to reduce and the gas leak is possible through the valve seat. Valve stem thickness reduces and it increases the clearance in between the stem and guide, leading to an engine oil leak. A bent exhaust valve can end up in the wrong position. It can also fail to seal properly when closed. This defect causes an exhaust leak that affects the way the fuel is combusted. The bent engine valve creates low compression because it no longer closes securely, thereby leaving the seal defective with the cylinder head. As air or exhaust escapes, the compression is thrown off, causing a lack of power and other performance complaints. Bent engine valves almost always lead to a lack of power. In many cases, these power issues come from a reduction of pressure in the cylinder caused by the damaged valve. When the valve doesn't close correctly or sit where it should, the combustion mixture will be thrown off. So, it is necessary to inspect the valves for their defects thoroughly. Now, we are going to learn how to inspect the valves. Valve stem end deflection. If bore gauge is not available, check end deflection of the valve stem with a dial gauge instead. Move stem end to and fro to measure end deflection. If deflection exceeds its limit, replace valve stem and valve guide. Visual inspection. Remove all carbon from valves. Inspect each valve for wear, burn, or distortion at its face and stem end is necessary. Replace it. Inspect valve stem and face for pitting and wear. If pitting or wear is found there, the valve stem end may be resurfaced, but not too much to grind off its chamber. When it is worn out too much that its chamber is gone, replace the valve. Valve head radial runout. Check each valve for radial runout with a dial gauge and a V-block. To check runout, rotate the valve slowly. If runout exceeds its limit, replace the valve. Seating contact width. Create a contact pattern on each valve in the usual manner, that is, by giving a uniform coat of marking compound to the valve seat and by tapping the seat with the valve head. A valve lapping stick must be used. The pattern produced on the seating face of the valve must be a continuous ring without any break, and the width of the pattern must be within the specified range. Valve spring free length and preload. Check to be sure that each spring is in sound condition, free of any evidence of breakage or weakening. Remember, weakened valve springs can cause chatter, not to mention the possibility of reducing power output due to gas leakage caused by decreased seating pressure. Spring squareness use a tri-square and surface plate to check each spring for squareness in terms of clearance between the end of the valve spring and square. Valve springs found any problem, meaning a larger clearance than the limit must be replaced.
Now, let's have a recap of what we have learned in this topic. We have learned to inspect valve spring. Thus, we have learned how to inspect the valve assembly components. Hope you have clarity on this. Practice this exercise with the help of your instructor.